So that's why here we can write open interval 11 to infinity. This is the value of the interval of A is this one. Is it clear? Once again,
Can you explain again?
find the interval of A. Here required interval of A. Given 2 points 1, 2, another point is 2, 3, 4. Here given these 2 points are same side of this line. Same side of this line. So same side of the line means the condition is L11 into L22 greater than 0. Here first point is 1, 2 taken as A x1 y1, 3, 4 is B x2, y2. The given line is L. L is 3x minus 5y plus A. First of all, find L11 and L22. L11, substitute the point in L, that is 3 into 1 minus 5 into 2 plus A. So after simplification, L11 value is A minus 7. Next we find L22. L22 is nothing but the point, second point substituting L. 3 into 3 minus 5 into 4 plus A. So L22 value is A minus 11. From the given data, both the points same side of L. So if any 2 points same side of the line, the condition is L11 into L22 greater than 0. So L11 and L22 is there. So substitute these are here. In this list value, alpha is 7, beta is equal to 11. Here inequality is there. In quadratic equations, alpha beta are 2 roots. For these 2 roots, the inequality x minus alpha into x minus beta greater than 0, in which alpha is the least value, beta is the greatest value. The inequality can be written as x less than alpha or x greater than beta, or otherwise it can be written as less than alpha is nothing but left side of alpha. That can be taken as minus infinity to alpha union. Here greater than beta, right side of beta. So beta to infinity. So the inequality applying here. Here in place of x, here A is there. A less than alpha value 7. A greater than beta value is 11. A less than 7 or A greater than 11. It can be also written as like this. A belongs to left side of 7 from minus infinity to 7 union right side of 11, that is 11 to infinity. This is the final interval of A. Okay, no doubt. Next concept, point of intersection. Point of intersection of two lines. Point of intersection of two lines. Next concept. For example, given two lines like this, this one is one line. Two lines having only one common point, thus two lines are called the intersecting lines. This is the intersecting line. This can be taken as P. This one is first line L1. A1x plus B1y plus C1 is equal to 0. This can be taken as L2. Second equation, A2x plus B2y plus C2 is equal to 0. Point as intersection of two lines. we take any two lines, those two lines having only one common point, then the lines are called intersecting lines. Here intersecting point is P. Okay. Here find point of intersection. This can be taken as alpha comma beta. Intersecting point taken as alpha comma beta. Here P lies on L1 and L2 also. So the point P satisfies L1 is equal to 0. So A1 alpha plus B1 beta plus C1 is equal to 0. This can be taken as equation 1. Also P lies on the second line because P is the common point of these two lines. So P substitute in the second line also. A2 alpha plus B2 beta plus C2 is equal to 0. That is the second equation. Here two equations are there. We can solve any method, elimination method or substitution method or cross multiplication method. Here we use cross multiplication method. For cross multiplication method, for cross multiplication method, first of all we take the y term. Y term is beta value, beta coefficient B1. After that constant. Next alpha value or x coordinate A1. After that first term B1. Similarly from equation 2 also B2, C2, A2, B2. So this can be taken as alpha. Second one taken as beta. This one is 1. This is the process of cross multiplication. YCXY method. Y is nothing but coefficient of y, constant x and y. YCXY method or cross multiplication method. Now simplify this one. Alpha by multiply this one. First of all B1 C2, B1 C2. After that take minus multiply these two B2 C1 is equal to beta by multiply this one first of all C1 A2 minus A2 A1 is equal to 1 by A1 B2 minus A2 B1. Now equating first and last terms we got the value of A alpha. Second and third term equating we got the value of beta. Alpha is equal to first equating first and last terms from that alpha value B1 C2 minus B2 C1 by A1 B2 minus A2 B1 comma beta value. Now equating second and third terms. This can be taken into right side. Beta is equal to C1 A2 minus C2 A1 by A1 B2 minus A2 B1. Alpha beta. P alpha comma beta is the point of intersection of the given lines. This is the cross multiplication method. Otherwise, you can solve elimination method, substitution method, any method. Okay. Point of intersection of the given lines. Is it clear? Understood? Point of intersection. One problem discussed about related this concept. Find the point of intersection of 2x plus 3y minus 7 is equal to 0 and x minus 5y plus 6 is equal to 0.
Sir, 1 minute, sir.
Okay.
Yes, sir.
Now find one problem related to this concept. Find the point of intersection of 2x plus 3y minus 7 is equal to 0 and x minus 5y plus 6 is equal to 0. Solution. By cross multiplication method. By cross multiplication. By cross multiplication method. First of all, y c x y. Y value 3. C constant is minus 7. X value 2. Again y 3. Now take from the second equation. Y value minus 5. C value 6. X value is 1. Y value is minus 5. So first of all, the value of first value is x, second value y, last is constant. Now simplify this one. X by first of all multiply this one. 3 into 6 minus. Now multiply these two. Minus 5 into minus 7 is equal to no y. Y by minus 7 into 1 minus 6 into 2 is equal to 1 by 2 into minus 5 minus 3 into 1. Okay. X by 6 into 3, 18. Minus of minus plus, plus into minus, minus 5 into 7, 35 is equal to y by plus into minus, minus 7 into 1, 7 plus into minus, minus 6 into 2, 1 is equal to 1 by 2 into minus 5, minus 10, 3 into 1, minus 3. X by 18 minus 35, minus 17. Minus 17 is equal to y by minus 7 minus 12, that is minus 19. Okay, is equal to 1 by minus 10 minus 3 minus 13. Finally, we require the values of x and y. So, equating first and last terms, x by minus 17 is equal to 1 by minus 13. Minus minus get cancelled. 17 taken into right side, x is equal to 17 by 13. Now, equating second and last terms, y by minus 19 is equal to 1 by minus 13. Minus minus get cancelled. 19 taken into right side, y is equal to 19 by 13. So finally, the point of intersection of the given lines is the point of intersection of the given lines is x coordinate is 17 by 13. 17 by 13. Y coordinate is 19 by 13. Is it clear?
Balu sir.
Sir.
Okay. Already Jagdish sir already joined in the meeting.
Okay, sir. Okay, sir.
Tomorrow we'll continue. Okay, na?
Okay, sir. Okay, sir. Thank you, sir.
Okay, thank you, sir. Thank you very much.
Thank you, Ananda.
Jagadish sir, good evening.
Yeah, sir. Good evening, sir.
Okay, sir. Started.
Okay.
Okay, sir.
Good evening to all students. So yesterday we are discussing about the functional groups and its IUPAC names and few examples also we are discussing. And at present now we are going to discuss few more functional groups are there. And first one here after that acid chlorides yesterday we discussed. Now acid anhydrides. Acid anhydrides. So here acid anhydrides. So what is the general formula? Because this is the general name of functional group here, and we are discussing first of all general formula. So general formula means here first of all in this how the structure. So this is the common structure in each and every acid anhydrides. Here alkyl groups are there here both sides. Okay, R dash. So maybe they are same or different, no problem. Either we can take same alkyl groups or different alkyl groups. And I told you already, R means what here? Cn H2n plus 1. So R is nothing but alkyl group and its formula is CnH2n plus 1 here. So here secondary suffix in this functional group is anhydride. Secondary suffix is here anhydride. And if you take IUPAC name of this functional group here, how to write IUPAC name? General IUPAC name is here alkanoic anhydride. Alkanoic anhydride. So let us take one example. Few common names also are there. And first of all, I will take one example. Both sides of alkyl group here. Here I can write like this also. In the place of R, just I'm keeping CnH2n plus 1, COO, OCnH2n plus 1. You can write like this also. In the place of R, you can keep alkyl group. Now, if I'm taking both sides n is equal to 1, then what we are getting here? CH3, CO, O, CO, CH3. Simply, we can say this is these both parts are similar. So that's why we can write here CH3CO. It is twice here, twice O, because 2 times it is repeated, both sides of the oxygen. So we can write twice O. So we can write this one also. Both are same only here. Now here inside the bracket here, how many are there carbons here? 2 carbons. 2 carbons. 2 carbons. Actually, we should not take 4 carbons. Even it is containing 4 carbons, but here oxygen is breaking. Okay, both sides 2 carbons only. So you have to take here 2 carbons only you have to consider while you are writing the root word here. So 2 carbons means eth. So here in the place of alk we are keeping eth. And remaining part what here? Ethanoic. Enoic anhydride. Okay, ethanoic anhydride. So this is the IUPAC name of anhydrates here. Why? Because why we are writing ethanoic only? Even both sides 2 carbons are there, but we are considering only 2 carbons because actually this anhydride is formed from acids here. If I am taking acetic acid and another mole of acetic acid, 2 acids combined to form, okay, 2 acids combined to form anhydride along with water. This is actually how anhydride is formed here. So both two acids, either same acids or different acids. So both combine to form anhydrates. That's why this anhydrate is formed from ethanoic acid. Ethanoic acid, 2 moles of ethanoic acid we are taking. That's why this is called here ethanoic anhydrate. So that's why we are considering only 2 carbons because the anhydrate is formed from ethanoic acid. Now, if you take different alkyl groups, so different alkyl groups means what here? Yes, both sides you can take here. For example, I'm taking CH3CO, and so another side here, I'm taking CO. This part is common, but alkyl groups is different. So here alkyl group containing 1 carbon, but here alkyl group containing 2 carbons. So here different alkyl groups are taking. So here this is actually ethanoic we can write here. This is what 1 carbon means methanoic. So, but which one first we have to write while you are writing the IUPAC name? First you have to write the alphabetical order. E is first, later M. So, first of all, you have to write ethanoic. Here both you have to mention. If you are 2 different acids we are taking, from 2 different acids it is forming this anhydrate. That's why ethanoic, methanoic anhydrate. Both we have to write here. But if both are same, any one you can write here. So ethanoic, methanoic anhydride. If you different alkyl groups, then you have to see the alphabetical order of the first letter, which one is coming first. So that one you have to write, and later second alkyl group with methanoic anhydride. So this oic anhydride is common here. And here ethanoic, methanoic, based on the number of the carbons, we have to use the root word. So this is about the anhydrates, and any example you can write. If both are same, you have to mention only one root word. If both are different, then both names you have to write here. And one more important functional group is here acid amides. Acid amides. So acid amides. What is the general formula of acid amides? Means you can write RCONH2. RCONH2. This is a amide group. So generally, secondary suffix here we are using for this functional group is amide. Amide. So what is the IUPAC name? This is important. IUPAC name, which is here alkanamide. Alkanamide. Here this part is secondary suffix. This part is primary suffix. This part is called root word here. Okay. Now I'm taking one example here. So general formula again I'm writing here CnH2n plus 1. Nothing but in the place of R, we can keep CnH2n plus 1 and CONH2. Now I am taking n is equal to 0 also we can take. Why? Because here H is coming if n is equal to 0, but here carbon is there. In the functional group also one carbon is there. That one also we have to count here. So it contains one carbon. So one carbon means root word is meth. So meth and amide, methanamide. Simply we can write methanamide. But another common name also is there. Formamide also we can write. This is a IUPAC name here, and this is the common name. Common name is formamide, but IUPAC name is important. According to rules, it contains one carbon, so root word is meth, and remaining part we have to add according to IUPAC name. An amide. An is the primary suffix, amide is the secondary suffix, meth is the root word. So finally, methanamide. But if I'm taking n is equal to 1, then we are getting CH3 here and CONH2. Here, these two carbons are continuously at both are combined here. So this is the continuous carbon chain. So two carbons are there. Two carbons means root word is eth. So ethanamide. Ethanamide. For this also one common name is there. Acetamide. Acetamide is the common name, but ethanamide is the IUPAC name. So like this here we can write so many examples. Okay, very simple thing here. You have to count the carbon which is also containing in the functional group, because it is continuously connected with the alkyl group carbons. That's why you have to count that carbon also while you are writing the root word. So very simple. And next one more functional group is amines. So generally amines, if you see here amines, general formula of amines, this is very simple. RNH2. RNH2. Here R is no, we know already. R means what? Cn, H2n plus 1, NH2. And we want IUPAC name. So IUPAC name is here alkanamine. Alkanamine. So here alk is the root word. An is the primary suffix and amine is the secondary suffix. Very simple thing here. And now let us see here one example. If you substitute n is equal to 1, here 0 is not possible because no carbons are there in the functional group. So from alkyl group only we are getting carbon. So minimum we should take 1. So CH3. If you are substituting 1 in the place of n, then we are getting CH3 NH2. CH3 NH2. Now, according to IUPAC name, how many carbons are there here? Only one carbon. So one carbon means meth. Okay, and remaining part you have to add as usual in amine, methanamine. Simply what we can say? Yes, methanamine. Or you can take n is equal to 2. N is equal to 2 means we can write here CH3, CH2, NH2. Or in the place of CH3, CH2, you can write directly C2H5 also. Both are same. So here two carbons. Two carbons means root word is eth and an amine. So ethanamine. So like this here, we can write the amines and their IUPAC names. Generally here we can say degree of amines also we can discuss, because we are already discussed about the degree of carbons and degree of hydrogens. Degree of amines means what here? Here in the amines here, nitrogen is connected with 2 hydrogens and 1 alkyl group, then it is primary amine. We can say this is called primary amine. If nitrogen connected with only 1 hydrogen, but remaining both are alkyl groups, then it is called secondary amine. Secondary amine. If nitrogen connected with all are alkyl groups only, no hydrogens are there. No hydrogens, only alkyl groups are present. So these alkyl groups are either same or different, no problem. So this is called here tertiary amine. Tertiary amine. So this is about degree of amines based on the number of alkyl groups connected with nitrogen. We can say here 1 alkyl group, primary amine, 2 alkyl groups, secondary amine, 3 alkyl groups, tertiary amine. In the primary amine, 2 hydrogens are present, definitely. Okay, in the secondary amine, only 1 hydrogen is present. But in the tertiary amine, all are alkyl groups only, because nitrogen valency is 3 only, maximum here. That's why all alkyl groups are there. So there is no space for hydrogen here. So this is about degree of amines here. And next one more functional group is here, nitroalkanes. So nitroalkanes. Generally, nitro group is a substituent only, and it is also very simple thing. And general formula is here RNO2. RNO2, nitro group here. RNO2, or we can say CN. In the place of R, we can keep alkyl group CnH2n plus 1 and double bond, and it is dative bond. Dative bond means one lone pair is donated to the oxygen. So we can write the structure like this. And what about IUPAC name? IUPAC name. And IUPAC name is simply nitroalkanes, because nitro group is always acts as a substituent. It is not actual functional group. It is actually a substituent only. So, but we have to know how to write, even substituent is there, how to write the name, IUPAC name here. Now you can keep N is equal to 1. Then we are getting CH3NO2. Then what about name? So same here, you have to substitute alk in the place of alk. How many carbons here? 1 carbon only. So nitro is common. In the place of alk, we have to keep root word meth, because it contains only 1 carbon. And as usual, remaining part nitromethane. If you N is equal to 2, so CH3, CH2, NO. Now we can write here nitro. How many carbons in this example? 2 carbons continuously connected. So nitroethane. You can write like this here, IUPAC names. And next one more functional group here. I'm giving one more functional group, that is cyanides. I think you heard this word cyanides. So cyanides means what is the general formula of cyanides? Here RC triple bond N. So these are called cyanides. So cyanides. So here cyanide is the functional group CN. Functional group is CN. And here if you see secondary suffix is here nitrile. Here secondary suffix is nitrile. Okay, and common name also here we can write common name for this here. Common name is alkyl cyanide. Alkyl cyanide also we can. But IUPAC name is important here. IUPAC name, which is here alkane nitrile. This is important. Alkane nitrile is the IUPAC name. Alkyl nitrile. So let us see here CN H2N plus 1 C triple bond N. So this is the general formula. Here this carbon is connected with alkyl group. So that's why you have to count this carbon also. While you are writing the root word, you have to take this carbon. You have to consider this carbon also, because it is directly linked with the alkyl group here. Now, if I am taking N is equal to 1, then what we are getting the formula? N is equal to 1 means CH3, C triple bond N. Now here how many carbons? 1 and 2. Both carbons are connected, continuously connected. So 2 carbons means what is the root word here? Eth. If you see the IUPAC name, this is the IUPAC name. According to this, you have to write the name. So in the place of alk, I am keeping eth. Remaining part is as usual. Ane nitrile. Ethane nitrile. Okay. But common names also are there here for this. This is what I wrote here. This is IUPAC name. But common name is here methyl cyanide. Methyl cyanide, because this is common name. Here, completely CN means cyanide, they are taking commonly, and CH3 means methyl. Or one more common name also is there for this year, which is acetonitrile. Acetonitrile also nothing but CH3CN only. So common names you have to remember, but IUPAC names according to rules we have to write. If I am taking N is equal to 2, then I am taking formula, I am substituting C triple bond N here, CH3, CH2, C triple bond N, or you can write directly C2H5, C triple bond N. Now here, how many carbons in the longest continuous carbon chain? 1, 2, 3. So 3 carbons. Then 3 carbons means what is the root word? Prop. So prop and remaining part as usual, propane nitrile. Propane nitrile. But you can write one more name here. Ethyl cyanide is the common name. So ethyl cyanide is the common name. So like that, you can write cyanides and its IUPAC names and examples and how to write a example with IUPAC. And one more last and final, isocyanides. Isocyanides. And just you have to remember, no need to confuse. Okay, no need to by heart because we are doing again examples. Then you can remember easily. We will see now rules also. First of all, general formula for isocyanides is here RN double bond C, and this is the dative bond from nitrogen to carbon here. This is the isocyanates general formula. Here R is the alkyl group only as usual. So here IUPAC name actually not there here for this type of compounds, but you can write the secondary suffix. So secondary suffix which is isocyanide or isonitrile also we can write isonitrile. Now how to write? Only common names are there for this type of functional groups. This one. So if I am taking N is equal to 1, so here because alkyl group means CN, H2N plus 1, N double bond C here. For this common name only we should write here. So for common name means what here? If N is equal to 1 means I am substituting here CH3, N double bonds. Now according to this one we can write here. Here methyl group is there, here isocyanide group is there. So we can write methyl isocyanide. This is the common name only. Or one more common name also is there. Methyl carbyl amine also we can write. Methyl carbyl amine. Or one more name also we can write, which is methyl isonitrile. These are all the common names only. Okay. Or if you take N is equal to 2, then what we are getting? CH3, CH2, N double bond C. That means dative bond also is there. So triple bond only we can consider. So here same we can write here. Ethyl. Why ethyl? 2 carbons here in the alkyl group. So ethyl isocyanide. Isocyanide means NC part. This part is isocyanide. Or ethyl carbyl amine. Ethyl carbyl amine. Or ethyl isonitrile. So you can write like this here. So these are all the functional groups and its common names and IUPAC names. Now, here we are going to discuss about the few rules while you are writing the nomenclature for branched chain alkanes. First, we are going to discuss about branched chain alkanes. Already few rules we discussed here, but again we are going to discuss now. And first one is here longest chain rule. Already I told you we have to select the longest chain. For example, I'm not keeping hydrogens. Generally, I'm doing here. Already we discussed this point before. If I'm taking like this, which one is the longest chain? You can take in this example. Yes, I'm taking like this. This is the longest chain. So just I'm selecting longest chain. Okay, I'm discussing about how to select the longest chain. Longest chain means continuous carbon chain should get more number of carbon atoms we have to get here. Then it is the longest chain. For example, I'm giving one more example here. Hydrogens also are there. Just I'm not keeping for you because I think you understood here. Okay. So in this skeleton, which one is the longest chain? We have to select here. If you are going to straight, only we are getting 5 carbons. Okay, straight chain. But if you are going like this, 1, 2, 3, longest continuous carbon chain only. You should not come back here. This is the longest continuous carbon chain. If you consider this chain here, 1, 2, 3, 4, 5, 6, 7. So continuous here because it is getting like this. Okay, continuous chain only this one. Okay, should not come back again when you go in one path. So this is continuous carbon chain. So we are getting here 7 carbons. So I think this is the longest possible continuous carbon chain. So this is about how to select the longest chain. Next, one more point here. You have to here larger number of side chains we have to select. Next one is here larger number of side chains. What is the meaning larger number of side chains? Here, I will give an example. You will get clarity. In few structures, 2 possible chains are there. 2 chains are possible with the same number of carbon atoms. For example, if I am taking like this, same structure again, I'm drawing here. Just I'm keeping. So why I wrote this example here? There is a possibility is there. What is that possibility? Longest continuous carbon chain is straight chain means if you are taking here how many carbons? 1, 2, 3, 4, 5, 6. But even here also we are getting 6 carbons, but this is another way. Okay. So if 2 chains of equal lengths are possible, then which one is correct? Again, you have to select the correct one because correct one is only any one only correct. So select the one with larger number of side chains. Large number of side chains. Side chains means what here? So, for example, this is the parent chain in the first numbering. So the parent chain is connected with this is one substituent, this is another substituent. But here connection only here one connection, this one only connection. So this total here only one substituent because this total part connected to only one carbon. Okay, this longest chain is called parent chain. I told you. For parent chain, here how many connecting 2 substituents are connected with 2 carbons, but here only with 1 carbon. So this is totally one substituent. But we have to select more number, larger number of side chains. Here 2 side chains are. So more number of side chains for which parent chain is possible, that one only we have to select here. Here one side chain is present here. So which one is correct? 2 side chains, but not this one. Because if both are having equal length, parent chains having equal number of carbon atoms, then more number of side chains is possible for which structure? That structure only we have to take. That is the correct one. So I think you got clarity here. And next here, lowest number rule. This is also important rule. Lowest number rule means what? For example, if I am taking the structure here. So same the structure here, once you see, we have to select the longest chain. So I think, you know, when you are seeing, you can easily identify straight chain is the longest chain. Now, this is called what here? Substituent or side chain. We know already. And this is called what here? Parent chain or longest chain. Okay. So first of all, after selecting the parent chain, actually we should give the numbering. Numbering means either left to right or right to left. So okay, I'm giving 1, 2, 3, 4, 5, 6. Or you can give from this side also 1, 2, 3, 4, 5, 6. Now, which one is correct here in these two? They will ask here. Any one numbering only correct. Which numbering is correct? So here I told you lowest number rule. Lowest number means for substituent. Here substituent is connected with which carbon? This carbon. Okay, substituent is connected with the third carbon according to this numbering. But according to this numbering, okay, this carbon numbering here 3. Substituent connected with the parent chain carbon numbering is 3 in one way. Another way 4. Which one is least number? Yes, first one is least number. So that's why you have to select this one. So this is wrong chain. Why I am taking this numbering only? Because the substituent which is connected to the carbon should get the least number while you are giving the numbering. So, but in this way, we are getting 4 highest number, but here we are getting least number. So it is wrong, it is correct. Understood here, lowest number rule. Okay, where substituent is present, which is connected to the parent chain, that carbon should get the least number while you are giving the numbering. So that 3, that number 3 is called here locant. That number 3 is called here locant. Okay, or we can say this is also called here positional number. Positional number. Positional number here. So now, you can ask one more doubt here. If more than one substituent is there, then how? Then we have to use lowest set of locants rule. Lowest set of locants rule. That means if more than one substituent is present, then how to give the numbering? Okay, I will give one structure here. You can see easily. Okay, so if you see here, first of all, we have to select the longest chain. Okay, longest chain means, okay, I am selecting this one because already I told you this example before. So this is the longest chain. So in the longest chain, already we selected. Now we should give the numbering from top to bottom or bottom to top. So here I am taking 1, 2, 3, 4, 5, 6, 7. Okay. So I'm giving numbering and one more possibility also here I will draw again. So this is the longest chain. Same structure I'm taking here. Now I'm giving in the reverse also 1, 2, 3, 4, 5, 6, 7. Okay. Both are having 7 carbons, which is the longest chain. But here we have to see lowest set. Lowest set means, first of all, locants. So this is the side chain. This is another side chain. This is side chain. This is another side chain. This side chain is connected with the third carbon. So here third. This side chain is connected with the fourth carbon. So 4. Here once see the locants. Here 4, 5. Because the side chain is connected with 4. This side chain is connected with 5. So here 3, 4, 4, 5. So which one is the lowest set? Lowest set means you can add this. They have 7. If you add this, 9. So this is the lowest set. Clarity here. Okay, understood, I think. So we have to select this one only correct. This is wrong. We have to select the lowest set. So lowest sum. Also, we can take sum is lowest if more than one substituent. Either 2 substituents or 3 substituents. But we should select the lowest set of locants. Then that numbering is correct here. So this is about this rule, lowest set of locants rule here. And next year, one more example I am taking, just to see here how to write. Now here, in this example here, yeah, we can select the longest chain. How to select here? This is the longest chain. Here, how many substituents? 1, 2, 3 substituents. Okay, I'm giving numbering from left to right and right to left. 4, 5. Yeah. So here 2 numberings I'm giving. So in the first numbering, so this is the first numbering and this is the second numbering. So what is the locants? For this substituent, 2 is the locant. For this substituent also, 2 is the locant. And for this substituent here, 4. Okay, clarity here. This is the first numbering locants, substituent positions. And second numbering here, yeah, for this here, this is a 2. Here 2. And here both substituents are present in the fourth carbons here. Okay, 4, 4. Now, according to this 2, if you observe here, which one is the lowest set here? If you add all, here we are getting 8 sum. Okay, here we are getting how much here? 10. So this is the lowest set. So this is the correct number. This is wrong number. First numbering is correct. Second numbering is wrong because we are getting the lowest set in the case of first numbering from left to right. We are giving here 1 to 5 here. So this is about how to write if more than one substituent, then we have to select the lowest sum. Now name of branched chain alkane next year. So name of branched chain alkane, how to write name. So already this point, I think you got clarity here. Just I'm taking one example. So if I'm taking this example, how to write the name. Before going to write the name, first of all, we discussed a few rules above. You should follow that. First, we have to select the longest chain. Okay, this is the longest chain. And next, we should give the numbering. So numbering means how to give the numbering. If substituent should get the least number, I told you. So from left to right only we should give. Because here methyl group should get least number from left to right only. That's why it is getting 2. Now, okay, that's okay. And next we have to write the name of the this compound here. So first, always we should write the side chain name. So what is the side chain here? CH3. CH3 name is methyl. We know that. And it is present in which position? Second position. So 2 dash. Because between the number and the letter, we should write hyphen. Okay. Between the number and number means we should write comma. Between the letter and letter, no need to give the gap. Just I'm giving an example here. Between the number and letter, hyphen we have to write. Between the number and number, we should write comma. Between the both are letters means no need to give any gap here. So here 2 methyl. Okay. Second carbon containing methyl group. So that one completed. Substitute name completed. And remaining part what here? Side longest chain containing how many carbons? 4 carbons. For 4 carbons, what is the root word? But. So but. After that, all are single bonds. So we have to write the suffix in, butane, because all are single bonds only between the carbons. So 2-methyl butane. Butane. I think you got clarity here how to write the name of this compound. And I will give one more example. You can say this CH3, CH2, CH, CH2, CH3. And here I'm taking, 3 carbons. So first of all, always we should follow the first rule is select the longest chain. So longest chain is generally straight chain only we can take as a longest chain. Okay. Next, who is the substituent here? This is the substituent. 2 carbons. That means it is ethyl group. Okay. And we should give the numbering and the substituent should get the least number. So I am taking 1, 2, 3, 4, 5, 6. Okay. So now 3 is the least number because if you are giving this side also, but it is wrong numbering. Why? Because your substituent is getting 4, but your substituent is getting 3, least number. So it is correct, it is wrong. Now, third carbon containing ethyl group is the substituent. So 3 ethyl. And in the longest chain, how many carbons? 6 carbons. So hex. Okay. And all are single bonds. So N. So 3 ethyl hexane. So I think you got clarity here how to write branched chain alkane with one chain only, one side chain. If 2 side chains, how to write now? I will tell you. Next model. So next here, if 2 side chains are there, then we should give the names with alphabetical order. Already I told you this point here. Alphabetical order of side chains. We have to see if more than one side chain is present. That means I will give one example here. That means if 2 or more alkyl groups are side chains present in the parent chain. So according to alphabetical order only, we should write while you are writing the name of the structure here. So I'm taking one example CH3, CH, CH3 here, CH, CH2, CH2, CH3, and here CH2, CH3. So let us see here in this example. So first of all, we should select the longest chain as usual. So longest chain means generally as usual, longest chain is this is the straight chain is the longest chain. Okay. Now after that we should give the numbering. So I told you already before when more than one side chain is there, then we have to take lowest set. This is the correct numbering because 2 and 3 are the locants of these 2 side chains and this is the lowest set. So no need to see here. I think you can identify easily lowest set. And later we should write the IUPAC name. How to write IUPAC name? First of all, here I told you alphabetical order we should follow. So what is the name of this side chain? Methyl. This name ethyl. Which one is first in the alphabetical order? Ethyl only first. So what is the position of ethyl? 3. So 3 ethyl. First you have to write 3 ethyl. Because it's a alphabetical order, this is first. E is the first we are getting. And second one is methyl. So methyl present in second position. 2 methyl. Here I am telling you already between the letter and number hyphen we have to write. Between the number or letter hyphen we have to write. Okay, anything here. So 3 ethyl, 2 methyl. So substituents completed. Name of substituents we are writing already we wrote. And later longest chain containing 6 carbons. So 6 carbons means root word is hex and all are single bonds in. I think you got clarity here. 3 ethyl, 2 methyl, hexane. Okay. So this is about how to write if more than one side chain, then we should take alphabetical order. Now, one more model I'm giving here. In this model only, another model, this type of rules here, somewhat different here. Why it is different? Actually, if you are seeing that example, this example, both are similar only, but one different point is there. What is that? So let us see now. I am selecting the longest chain. You can identify. So longest chain, I'm giving the numbering. I'm giving left to right 1, 2, 3, 4, 5, 6, 7. You can write from right to left also 1, 2, 3, 4, 5, 6, 7. But which one is correct? I told you already. Substituents positions here 3, 5. But this side also 3, 5. So both are same. Here 3, 5 and here also 3, 5. Both are getting same set. If both are getting same set, then how to select which one is the correct numbering? Then you have to see the alphabet of first letter of side chain. This is ethyl and it is methyl. So according to alphabetical order, first one is always ethyl only. So ethyl should get the least number because of due to alphabetical order. So 3 least number. 5 is coming to the methyl only. Why we are taking like this? Because if both are getting same set of locants, then we should consider the alphabetical order and which one is coming in the alphabetical order first, that should get the least number. So this numbering is correct, this one is wrong. Now how to write this name, IUPAC name? So here 3 ethyl and after that 5th carbon containing methyl and total number of carbons in the longest chain 7. And what is the root word for 7 carbons here? Hept. Hept is the root word and ane as usual all are single bonds. So 3 ethyl, 5 methyl, heptane. So I think you got clarity here. If both are getting same set of locants, then we should consider the alphabetical order of the substituents and which one is coming in the first one, that should get the least number while you are giving the numbering of the parent chain. And next year, one more, I'm giving one more example. This is another, if I'm giving 3 substituents here, CH2, C, CH3, CH3, CH3. So how to write this one? So as usual, I am selecting the longest chain and you should give the numbering. So here, first of all, 3 substituents are there here. So you can take any side here, but lowest set we have to take 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. In the first numbering, so what are the positions? Locants, substituent positions. What here? Here 2 is the substituent position. Here 4 for one methyl group. For another methyl group also 4 because both methyl groups are present in the 4th position. This is the first numbering. According to that, these are the locants. But according to second, 2, 2, 4. So this is the lowest set. Is it correct or not? This is lowest set. This is wrong. Now, how to write the IUPAC name? Here, all are same type of alkyl groups. Okay, all are same type. All are methyls only. So directly you can write 2, 2, 4. You have to write at a time. And 3 times it is repeated. So that's why you have to write trimethyl. Okay. So why we are writing tri? Because here all substituents are same. So same means you have to use tri. And their positions also you have to write here. Trimethyl, okay. But these 3 methyl group present in which positions? One methyl group is second position. Second methyl group is also second position. And another methyl group at fourth position in the parent chain. So 2, 2, 4 trimethyl and as usual the parent chain 5 carbons. So pent and ane all are single bonds. So 2, 2, 4 trimethyl pentane. So I think you got clarity here. Okay, how to write it? Very simple. But now I'm getting a different new example. So see carefully. This example you have to listen carefully here. This is somewhat different here. CH. This is actually called complex substituents. So complex means what? Just see this example and you can understand easily. Somewhat big structure here, but no problem. According to rules, we can follow. So first of all, we have to select the longest chain. Okay, I'm selecting 1, 2, 3, 4, 5, 6, 7. Yeah, in this way, if I'm taking the longest chain, I'm getting more number of carbons. That's why I'm taking this is the longest chain. So how many carbons? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. And you should give the numbering from left to right only because here methyl groups, the substituents are getting least numbers. And one more substituent is there. What is it? This is the big substituent connected with 6 carbon. This type of substituents are called complex substituents. Why it is called complex here? Because again internally there is a chain and there is a branch again. Okay, in the substituent. So that's why it is called here complex substituent. If complex substituent is present, then again you should give the numbering internally in the complex substituent where carbon atom is connected here in the 6th carbon. So from this 1, 2, 3, you should give the numbering again. Okay. So 3 carbons in the straight chain, but again one more substituent again. For the substituent again another substituent methyl. So first of all here here the second carbon and third carbon as usual 2, 3 dimethyl you can write because di means 2 times. 2 and 3 are the position of methyl groups. This is over. But 6th carbon containing a complex substituent. How to write? You have to use the brackets here for complex substituent. So first of all, internally in the complex substituent, here again 3 carbons in the straight chain. In the second carbon, again substituent is there. What is the second carbon having? Methyl. Okay. Second carbon having methyl and this chain containing how many carbons? 3 carbons. So we have to take propyl because it is also substituent. So that's why I write 2-methyl propyl and close the brackets because we are writing already we wrote complex substituent name. So second carbon internally again containing methyl group on propyl. In the propyl group, second carbon containing methyl group again. So in the propyl group, again second carbon containing methyl group 1, 2, 3, and this one. This is overall present in another carbon. This is the parent chain carbon. Understood here? So 2-methyl propyl. This is the complex substituent name. Completed. Now finally, how many carbons in the longest chain here? 10 carbons. So 10 carbons means tech is the root word. Tech is the root word for 10 carbons. All are single bonds in. I think you got clarity here. How to write the name for complex substituent. Okay, and I will give one more example. You can see here easily. You can understand now. So see this example. Now you will get clarity completely. So see clearly, I'm giving a longest chain, bigger structure, but no problem, very easy structure. First of all, you have to select the longest chain as usual. So in this structure, yes, I'm selecting the longest chain. This is the longest chain. Yes, and this is the longest chain. I'm going to down. If we are getting more carbons, then we are going to down. And here this is continuous chain. Yeah. Now from this side only I'm giving numbering because the substituents are present in the bottom side. So 3, 4, 5, 6, 7, 8, 9, 10. Why I'm giving from bottom? Because here substituents are there. 1, 2. This is the complex substituent again. So total 3 substituents. Okay. In this 3 substituents here already 3, 3. Because 2 times I'm repeating. Why? these two methyl groups present on the third position. So dimethyl, 3 comma 3 dimethyl, 3 comma 3 dimethyl. After that, you have to write the complex substituent name. So complex substituent present in the fifth position. So in the fifth position, you have to write the square, start the square brackets. Again, we should give the numbering internally. 1, 2, 3, 4. And this is the side chain again. So second carbon having ethyl group side chain and totally 4 carbons in the complex substituent straight chain. So 4 carbon means butyl. So this is the name of side chain, name of the side chain, complex substituent here. 2 ethyl butyl, because this is again the longest chain. And again, this is the substituent. So in the second carbon, ethyl, and overall this is called butyl, because all are substituents one. And later, as usual, 10 carbons. So root word is dec and ane, decane. 3 comma 3 dimethyl, 5, 2 ethyl butyl, decane. But generally here, you can write first to this one, because this one you can write first here. Why? Because here E is the letter which is coming in the alphabetical order first. But here M, methyl. So you can write this side here, no problem. This one here, write exchange. You can exchange it. Alphabetical order you can follow here. That's why I'm telling you. Okay. So any doubt here? So branched chain alkanes, how to write? I think you understood. And tomorrow, next class, in the next class, we will discuss about unsaturated compounds, how to write the names. So these are all saturated compounds and branched chains and complex substituents or one side chain, more than one side chain. So these are all the models we discussed today. Okay. And any doubts you can ask. Otherwise, we will close the session.
Sir, last one once again.
Here, last one, same model I told you. First of all, select the longest chain. And these are the substituents. This is the complex substituent. In the complex substituent here, again, we should give the numbering inside again. 4 carbons. And the second carbon having again another substituent, ethyl. So that's why here 2 ethyl. And 4 carbons means butyl. 2 ethyl butyl. Which is present in which carbon? This complex substituent, 5th carbon. Okay. And later third carbon containing 3 comma 3 di means 2 times repeated. So methyl group, the 2 times which group is present here? Methyl only. So you have to mention the positions and its prefix, numerical prefix. This is di, 3 comma 3 dimethyl, and this one complex substituent. And later decane means what here? 10 carbons present in the longest chain. That's why dec. We have to use the root word decane. Okay. Okay.
Okay, Jagadish sir. Okay, na?
Okay, sir. Completed. You can.
Okay.
Yeah.
Okay. Thank you, sir. Thank you very much, sir.
Okay.
Okay.
Sir.